Hey everyone, in this video we'll go through the idea of patterns and we will start with an example. Alright, so with fx equals to x plus 2 over x minus 1, where x is any real number and x obviously cannot be 1 because that will make the denominator 0 and you can't divide by 0, I think that's a given. The question wants to find f2x and f2012. Seems a bit difficult, right? Especially the last one, but let's just take it step by step. If they want us to find f2x first, let's just find f2x first. So if fx equals to x plus 2 over x minus 1, now one way to do it is to sub every x with fx, so you literally have x plus 2 over x minus 1 plus 2 over x plus 2 over x minus 1 minus 1. This is one way to do it, then you just simply times x minus 1 on the numerator and the denominator. Another way is use basically just perform your long division, or you can just simply make it easier by having x minus 1 plus 3, and then you know it's gonna be simply 1 plus 3 over x minus 1, and you just substitute 1x, although you have to kind of get rid the 1, or you need not to, really depends. So either way it really works. I prefer the second way, so I'll just continue from here. So I'll get f2x first. Whoops. So f2x simply just replace every x with fx, which is replace this 1x with x plus 2 over x minus 1, and don't forget the minus 1 outside. Now it's a similar method to the first method, where you just times x minus 1 for the fraction on top and below the numerator and denominator to give you 3x minus 3 over below is simply x plus 2 minus bracket x minus 1, which is simply minus x plus 1. This then leads us to 1 plus 3x minus 3 over 3, and then this would then give us x. Alright, because 3x minus 3 over 3 would give us x minus 1 plus 1 equals to x. If you're curious about the method down here, right, it's actually the same thing. Alright, it's just simply x plus 2 plus 2x minus 2 over x plus 2 plus, minus x plus 1. On top you get 3x, below you get 3. This will also give you x. Alright, so either way it works. I mean, it's just a different way of expressing. You should get the same answer anyways. So we know that f2x equals to x. Now, what do you notice? If f2x equals to x, then f3x would simply be fx, right? Because you just replace every x with fx. And what you then notice is that this pattern will just carry on, right? f4x is f2x, which is basically x. And then it just repeats, right? So every odd number is fx and every even number would be x. Or what you can put it this way is every multiple of 2 would be x. And then a number that's not multiple of 2 would be something else. So that's one way to do it. So because this is quite easy, we know that f2012x is simply x. Alright, so this is one pattern, right? Another pattern, which I don't have the example right now, is basically fx equals to something, right? And then you have f2x equals to something. So let's say fx is something, let's say, oh yeah, fx is just fx. Let's make it easier. Then we have f2x being hx. Then f3x, oh, it's actually x. So then you notice that it's a multiple of 3 kind of thing. So what you do is simply, let's say if you want to find I'm going to give a random number in my head, let's say 1068x. Basically, first divide this by 3, right, and see what's the remainder. So can we tell whether this is divisible by 3? Well, divisibility of 3 rules is simply add all the digits together. If it's divisible by 3, it's divisible by 3. The whole number is divisible by 3. So we take 1 plus 0 plus 6 plus 8, this is 15, so it's divisible by 3, therefore this is x. Let's say we now have a different number because that was accidentally easy. Maybe change the numbers a bit, let's say 1079, alright? So now it's not divisible by 3, right, because now 1 plus 7 plus 9 is 17, it's not divisible by 3, therefore the 1079 is not divisible by 3. Now from here, right, what do you notice is that 1079 is basically 17, it's one away from being divisible by 3, so it is equals to f2, right? Because the next number that is divisible by 3 is 1080, so this is f2x, which is simply hx. All right. So this is just some examples that you see in the pattern recognition when it comes to composite functions. All right. So yeah, there we have it, the pattern questions in our functions.